Okay, very good morning children. In the previous class we had the discussion about the combustion and everything. Now we will be discussing about the some points regarding the calorific values. Okay, so what is a calorific value? First, what is a calorific value for a fuel? So when you burn 1 kg of fuel, how much amount of heat energy is produced? That is called as the calorific value of the fuel. Okay, calorific value means the amount of heat energy produced on complete combustion of 1 kg of a fuel is called its calorific value. The amount of energy, okay, the amount of heat energy, the amount of heat energy produced on complete combustion of complete combustion of 1 kg of a fuel, okay, is called its calorific, okay, is called its calorific value. Calorific value, okay, calorific value. It is expressed in kilojoules per kg, okay, kilojoules per kg. So this calorific value will determine the fuel nature. So in order, now we will be having, suppose in our daily life we will be using some water calorific some household things for burning. That is, we will be having LPG, CNG, all this. Now according to the order of calorific value of various, for competitive exams this order is important. Order of calorific value of various fuels. Which fuel has the highest calorific value, that will produce more heat energy. So that is the concept. So calorific values are what? Hydrogen gas of calorific value is greater than LPG, and LPG is greater than CNG, and CNG is greater than petrol, and petrol is greater than kerosene, and kerosene is greater than diesel, and diesel is greater than biogas, and biogas is greater than coal, and coal is greater than wood, and wood is greater than cow dung cakes. See, least calorific value is with whom means cow dung cakes. Cow dung cakes will produce least calorific value, and the highest calorific value is with what? Hydrogen gases. Okay, so these are the things. And already in the previous class, in the previous video, I said you very clearly, calorific, these fuels are of solid state, liquid state and gaseous state. Okay, fuels, already I have given this, but again once again, fuels are of solid fuels, liquid fuels and gaseous fuels. So in solid fuels, already you know the examples of the solid fuels. Solid fuels are what? Coal, coke, charcoal, wood, okay, charcoal and the wood. All these are the examples of wood, wax, paraffin. These are the examples of what? Solid fuels. And liquid fuels, petrol, kerosene, diesel. These are the examples of the liquid fuels. And gaseous fuels, already we had the discussion now, LPG, CNG, okay, hydrogen gas, all these are the examples of the things. And fuels with a high percentage of hydrogen gas will have more calorific value. That is most important. Fuels having higher mass percentage of hydrogen will have higher calorific value. Fuels having higher mass percentage of hydrogen has higher calorific value. Okay, calorific value. Example, you see the calorific value of if you take CH4, methane and C2H6, CH4 will be greater. Why? 1 carbon and 4 hydrogens, but here for 1 carbon 3 hydrogens only. So the mass percentage of hydrogen is more here when compared to here. So methane has the highest calorific value. So that is the most important thing. So already you know what are fuels. Fuels are nothing but which materials will produce a large amount of heat energy. Those are called as the fuels. Okay. So these things you can note down. And we had one small discussion, final discussion which is left, that is regarding the flames. Okay. Under the flames. So in the diagram, in the previous diagram I have given like this. Okay, innermost layer, outermost layers. Okay, so that diagram you can check. I will be giving a detailed notes of all those points now. Very small topic is left. So you can note down if you have not noted the definition of a fuel also. So what is a fuel? The materials which are burned to produce a large amount of heat energy are known as fuels. Fuels means what? The materials which are burned to produce a large amount of heat energy. Heat energy are known as fuels. Okay, are known as fuels. In the previous discussion we had how to control the fire and what is firefighting. I have explained, but notes I have not given now. So now we will be having the notes for that control of fire. Okay, the control of fire. How you can control in case of fire accident. eliminating any of the three following requests. Generally, combustion is what first combustible material you have to remove, or you have to cut down the supply of the oxygen, or you have to lower the temperature of the fuel below its ignition temperature. So what is a fire extinguisher means? A fire extinguisher is a one which put off the device for putting off fires. Okay, so a fire extinguisher is a device used for putting off fire. That is called as a fire extinguisher. And the process of putting out the fire is called as firefighting. The process of extinguishing a fire is called firefighting. Okay, the process of extinguishing a fire is called as the firefighting. So these are the things which we have, and generally previously we had a discussion about the for different types of carbon dioxide fire extinguishers. Okay, dry powder fire extinguisher is used. Dry powder fire extinguisher will be there. Okay, extinct. Okay, EXIT. Extinguisher will be there. Next, soda acid fire extinguisher will be there. And foam type extinguisher is also there. We said foam type fire extinguisher. And already clearly I said to you, in dry powder extinguisher it is a mixture of soda. Okay, it is a mixture of soda and baking soda. Okay, baking soda, it is a mixture of baking soda, that is sodium. Baking soda means what? Sodium bicarbonate. Okay, sodium bicarbonate. Generally in a soda acid extinguishers, what will be happening? The same sodium carbonate will be there. Okay, sodium bicarbonate plus what will be there? In a metallic container, concentrated sulfuric acid is placed. Okay, a metallic container contains test tube. In that, concentrated sulfuric acid is present. Okay, that is about the soda acid for extinguisher. Okay, so these are all what? Carbon dioxide only. In this compulsory carbon dioxide will be there. Okay, carbon dioxide will put off the flames. So whereas the water can be also used. Where water cannot be used, there we will be using carbon dioxide fire extinguishers, and sand also can be used for put offing the fire. Okay, that is the major purpose. And foam type, so already you know that in this foam type, to get foam they will be adding a material called saponin or saponin. okay, or turkey oil. To get foam, they will add saporin, SAPORIN, or saponin or turkey oil. They will be adding these to get the foam along with sodium bicarbonate solution. Sodium bicarbonate solution will be there. See, baking soda is used for putting off the fire. Why means in baking soda, what will be there? NaHCO3. This will produce CO2. Okay, so that will put off the fire majorly. Is it clear? So that is the case foam type extinguishers. We are using these all. So with this, regarding the fire accident, how to overcome the fire accident and everything we have seen. So carbon dioxide is the, I can conclude like this: carbon dioxide is the best fire extinguisher. Okay, is the best fire extinguisher. Okay, carbon dioxide is the best fire extinguisher. Fire extinguisher for fires involving electrical equipments and inflammable materials. Already we had a discussion about what are inflammable materials. Okay, inflammable materials means what? The materials which catch the fire at a low ignition temperature only. Those are called as inflammable materials. Okay, so what are inflammable materials? The substances which catch fire with a flame, okay, at very low ignition temperature. If you take kerosene, LPG, petrol, all these are inflammable gases, inflammable materials. Inflammable means which catch the fire at very low. So you can see on the lorries, if it is carrying LPG cylinder or anything, it is written with red color very clearly: inflammable gas container. Means a small spark will create disaster there. Okay, the substances which have low ignition temperature can easily catch fire. Those substances are called as inflammable materials. Once again I am repeating, see, the substances which have very low ignition temperature. The substances which have very low ignition temperature can easily catch fire with a flame are called as inflammable materials. Okay, so this is the thing. So a fire extinguisher is a device used for putting off the fire, and the process of extinguishing a fire is called as firefighting. And for firefighting, most important one is carbon dioxide production. So carbon dioxide in a fire extinguisher can be produced by using dry powder fire extinguishers or soda acid fire extinguishers or foam type of fire extinguishers. In dry powder fire extinguishers, there will be soda, that is of baking soda, sodium bicarbonate. And in soda acid fire extinguishers, sodium bicarbonate along with a metallic container which consists of a test tube at the bottom. In that there will be concentrated sulfuric acid. Whereas in foam type fire extinguishers, to get foam we will be adding saporin or saponin, which is a type of an oil, okay, sodium to the sodium bicarbonate solution. Of all the fire extinguishers, Carbon dioxide is the best fire extinguisher for fires involving electrical equipments and inflammable materials. So what is an inflammable material? I have a clear discussion and given the definition also. The substances which have very low ignition temperature and can easily catch fire with a flame are called as inflammable substances. Okay. So this is all about the fire. Okay, now the last topic of this, that is about the flame. Already we had the diagram, but to give a clarity I am giving you the notes also now on flame. Okay, regarding flames, so a flame is produced as a result of rapid combustion. Okay, when a combustion substance is in vapor state, burns strongly in the presence of air, then a flame is produced. And mainly the flame consists of three zones. Innermost zone, that is called as the dark zone, and the second one is middle zone or luminous zone, and the third one is outermost or non-luminous zone. Already in the I have posted you the diagram to make it points in the previous class. So what is a flame means? A flame is produced as a result of a rapid combustion. When combustible substances is in the vapor state, and burns strongly in the presence of air, that is called as a flame. Okay. So generally, the greater the number of carbon atoms, the more will be the capacity to produce heat. Okay. So the greater the number of carbon atoms, the greater the number of carbon atoms in a molecule of fuel, the greater is the capacity to produce heat. Okay, and already in the previous class I said you the different zones of a candle I have already sent to you. Okay, so that only I am writing here. A candle mainly consists of has three zones. What are those means? Innermost zone, which is also called as a dark zone. Next, middle zone or luminous zone we call it. And next, outermost non-luminous zone. So a candle has three zones: innermost zone or dark zone, middle zone or non-luminous zone. Okay. So one by one the important points I will be giving to you. Innermost zone or dark zone is the least hot, or you can say coolest zone, coolest part of the flame, coolest part of the flame, and it is dark. Okay, so that's why it is called as dark zone, and no combustion will take place here. No combustion takes place in this zone. Okay, so these points are important for competitive exams, Olympiad exams, and all these. Okay, and next we have middle zone. Okay, middle zone is the largest zone. Okay, it is the largest zone of the candle, and it is moderately hot. It glows with an yellow light, and it is bright and luminous. And luminous zone of flame, mainly it is incomplete due to the burning of carbon. And in this case, the fuels like LPG and CNG, there is no soot formation also due to this luminous zone only. Okay, you can't see soot when you burn LPG or CNG. Okay, so that is the case. And the gases burn with a blue flame. Okay, so this is about this. So just you note down. Next we will be entering into the remaining points. Middle or luminous zone, luminous zone is the largest zone of candle flame. It is the largest zone of the candle flame and is moderately hot. Okay, it is bright and luminous. The carbon particles glow, emitting a yellow light. In case of a candle, okay, suppose in the case of flames, how it will be, we will see. Luminous zone of a flame is mainly due to incomplete combustion. Okay, incomplete burning of carbon. Okay, it is due to the incomplete burning of carbon. Okay, in case of fuels like LPG and CNG, that is a liquefied petroleum gas, and next what we have, CNG means compressed natural gas. Is it or not? CNG is compressed natural gas and LPG is liquefied petroleum gas. So in case of these, okay, there is no soot formation. There is no soot formation. Why? It is completely oxidized. So the gases burn with a blue flame. oxidizing hydrocarbons completely. So that's why you will be getting no soot formation in case of LPG or CNG. And see, innermost we have completed and middlemost also we have completed. Now we are left over with the outermost zone. So generally outermost zone is of blue in color. Is it or not? Okay. Outermost non-luminous zone of the flame is pink and blue in color. This is the hottest zone of the flame. This is the hottest zone of the flame. Okay. The temperature around will be 1800 degrees centigrade. The temperature of this zone is maximum around 1800 degrees Celsius. Is maximum around 1800 degrees Celsius. Vaporized wax gets oxidized to carbon monoxide and burns completely with blue flame in this zone. Okay, so this is the total content regarding the flames. Okay, so in the form of in the form of points I have given to you all this. Just you note down and go through this. So with this we have finished our total topic regarding combustion and flames, both at NCERT level as well as at competitive level. Okay, you can note down, and if you have any doubts you can WhatsApp. Okay.